A student places a mixture of plastic beads consisting of PP and PVC in a 1-liter beaker containing distilled water. After stirring the contents of the beaker vigorously, the student observes that the beads of one type of plastic sink to the bottom of the beaker and the beads of the other type of plastic float on water. The chemical structures of PP and PVC are represented by the diagrams below, which show segments of each polymer. Given that the spacing between polymer chains in PP and PVC is similar, the beads that sink are made of which polymer? Explain. As you can see, both PP and PVC are practically the same, except for one small difference: CH3 and Cl. In order to determine which one will sink, you're going to need to look at Cl's molar mass and CH3's molar mass. You can see Cl's molar mass is much higher than the molar mass of CH3, therefore making PVC sink. PP is synthesized from propene and PVC is synthesized from vinyl chloride. The structures of the molecules are shown below. The boiling point of liquid propene is lower than the boiling point of liquid vinyl chloride. Account for this difference in terms of the types and strengths of intermolecular forces present in each liquid. As you're going to be able to tell right away, both propene and vinyl chloride contain weak intermolecular forces like dipole-dipole and LDF. The major difference here is the CH4 and the Cl. Cl has a larger electron cloud than CH3. This makes vinyl chloride more polarizable and have a larger dipole moment, making intermolecular attraction stronger, also resulting in a higher boiling point. In a separate experiment, the student measures the enthalpies of combustion of propene and vinyl chloride. The student determines that the combustion of 2 moles of vinyl chloride releases 2,300 kilojoules of energy according to the equation below. Using the table of standard enthalpies of formation below, determine whether the combustion of 2 moles of propene releases more, less, or the same amount of energy that 2 moles of vinyl chloride releases. Justify your answer with a calculation. The balanced equation for the combustion of 2 moles of propene is shown as seen. This part is really simple, and it's only asking for products minus reactants. You're going to add everything on the product side and everything on the reactant side, and then subtract. I started off by multiplying CO2's enthalpy by its coefficient and added that to H2O's enthalpy, which I multiplied by that's coefficient, and then subtracted that by the reactants, which was C3H6's enthalpy times its coefficient plus O2's enthalpy times its coefficient. And then you should get an answer of negative 3858 kilojoules per mole. Our calculation proves that the combustion of 2 moles of propene releases more energy.